Okay, hi, this is Chandy Xue. I'm from Intel, and this is a team. We built the SIHG4SR, which stands for Site Information Heterogeneous Graph for Session Recommender System problem. So to the next page. Since we only have 10 minutes, so I just include the key contribution from our solution in these slides. I will talk about the graph, the site information heterogeneous graph representation. Then there are four main contribution, which is feature engineering, the train strategy, the hyperparameter tuning, and the multi-level model ensemble. Okay, so for the model, we are simply using a GNN-based model. So there are three phases in our model. The first phase is to convert the tabular data to the heterogeneous graph. I think you already know that there are multiple sessions in this data set. Actually, there are 1 million sessions in this data set. So each session will be built into a graph, like the one at the side. And so there are three types of nodes in the graph. The first type of node is item, which means when the user view the one item, then the next item, it will just link as the item sequence. Then we are using a second type of node, which is a feature. Since the data from data set, the feature is anonymous, but we are trying to think of the feature are meaning something. So we can think like the feature maybe means like the color is white, the length is long, the discount is 70%, something like that. Then we can think of like to link the item to the corresponding features. Then there is third type of node, which is a category, which means what is the feature category of this feature. And then we build this heterogeneous graph. Then we feeding this heterogeneous graph into our GNN, and we will have three types of embedding table because we have three types of nodes. Then the embedding table is item, feature, and the category. So we didn't aggregate these three types of nodes immediately, but we use two channels to propagate these two types of information. The first channel is only for the items, like this channel, and the second channel is for feature and the category aggregation. So it's very straightforward to think why we use the first channel only for the item, because this is a main information. And then this is something about the site information, which is a feature and a category. And to here, you can think there is a problem because the feature, the nodes of number of nodes is 7, but the item is only 5. So how can I to aggregate these two information together? This is how we are doing different type of reshape to the original embedding table. For feature, we will trying to doing the shuffling, which means like when white belong to item 1, item 2, and item 5, we will just add feature 1 to item 1, item 2, and item 5. Then we will have a new reshaped embedding table which share the same size as item. Then for the category, we trying to just doing a mean and broadcast because the category is more a general information. Then we add these two reshaped embedding table together as our site information embedding table and decode as a second logits. Then we fusion these two channel of logits together to get our final logits, and using a weighted loss. Weighted loss here means because this is a question about fashion, which means the most recent data will tell us more than the maybe 1 year ago data. So this is why we're using a weight to tell us that the data is recent or the data is years ago. So this is how we build our model. And then there are, as I mentioned, there are 4 key contributions to improve our score. The first one is the feature engineering work. So you already know that there are 3 types of node and 3 types of edges in our graph. then we are thinking that to put which kind of nodes into the graph maybe will either contaminate or either contribute to the final score. This is how we trying to just exclude one category of feature each time to see if there are some category maybe just contributing some conflict information into our GNN, which brought this score down. This is why we exclude the category 29 and 44. Then we also think about if there are any chance that we can build new features into the graph, which is because we have the timestamp in the data set, and we're thinking this is a very good source for new features. So there are 3 new type of feature we are creating. One is just to statistics or the history item click count to say, oh, okay, this item is hot, it clicked multiple times, and this item really being clicked 1 or 2 times. And the second feature is the elapsed time to the session end. Why we're adding this type of information? Because you can think that if one user opened a session maybe 2 hours ago, then she or he doing the purchase at the last 1 minute. So the last 5 minutes item she or he viewed contributes to most contacts she or he deciding than the 2 hours ago item. This is why we're using the elapsed time as a new feature. Then the feature item published time, this is another type of new feature. So besides the new feature we are creating, we are also thinking about, is there any chance we should drop the edges? This is what we draw in last bottom part of this slides. So firstly, we keep all the edges which has item sequence edges, the item to feature edges, the feature to category edges. Then we try to just remove the item sequence edges because we already have the elapsed time, so we may don't need to use the sequence. Then we also trying to doing a random drop of the edge with a probability of 0.1, and which help us to fix the overfitting issue. Okay. Then the second key contribution is the train strategy. So we are using two types of training strategies. The first one is just to loading the data set to create graph for each records, and then training using the purchase item as a label. Then we're thinking that since the next click also reviews the user's intention, right? So how about we using the next click to pre-train the model? Then we're using the real purchase item to train the model. It's something like borrowing from transfer learning. We can training a model with a bigger data set, then we train the real problem. So what we do here is like there's the first session is something like this. Then we augment it into 2 sessions. The first one is the first click, the Y is the next click. Then the second line is the whole session with the purchase item. And then because the data set is too big, and we found that only use the last 6 months of the data set is already enough. And this is how we're using train strategy to improve the score. So, so the last page here is the two main, another 2 contribution. One is a hyperparameter tuning, one is Ensemble. So we know that hyperparameter tuning is the key to improve the score when we already have a very mature model. So this is how we're using a tool provided by Intel named Intel End-to-End AI Optimization Kit, which using SIHG4SR as the search engine to help us to find the hyperparameter. So the page on the left side is how SIHG4SR shows the hyperparameter is finding, which is like the most strong line means this hyperparameter contributes the can help us to improve the score. And another thing we're doing here is Ensemble. So as you already know that we have different type of training strategy, we are choosing different features for the graph. So this is why we finally divide our model into 3 sub-model, which is V1, V2, and V3. And the V3 enhanced is just the hyperparameter tuning part. So we ensemble these 3 models together, and then we ensemble with V3, and then we got our last model, which scores like 0.2076 on the leaderboard, and this is our final score. And one thing we should mention that for the training part, we didn't use the candidate item, but for the predict part, because the JSCPy is providing the candidate item, I personally think that is something like the item is in stock or not. So we will apply the candidate item to our final prediction, which help us to improve the score more. Okay, so this is a score. This is our score here, and the link is listed here. The code and the hyperparameter tuning tool we are using. And I also show the difference between these 3 models. So if you're interested, you can check out this page or check out our paper. Okay, that's it.